Hi. Today I'm just going to talk about generating visuals with jit.gl.pix. This is a method that I've been using to generate some of my visuals lately, and I like it a lot. I feel that it has a very particular aesthetic that I'm very interested in right now, and it opens a pretty wide array of tools when it comes to generating mostly two-dimensional visuals from scratch. Of course, you can apply this to whatever context you may wish, but I just wanted to share some of my findings with the internet of working with jit.gl.pix. So let's just go for it. Most of these patches, I mean, you can, being a GL environment, you can either work with jit.gl.render or jit.world. Just for practicality, I just usually go for jit.world. If you have any reason for not wanting to use jit.world, then go for it. But in my case, I'm just going to go with jit.world. And I'm going to have it enabled from the start, and it's going to be floating. Something I like about jit.world, which is something you would have if you used jit.render anyways, but it's just the fact that it has an automatic clock output going from this outlet. So you can just use a send, and I'll just call it send bang. Send B, yeah, just send B. And this bang is going to be used to just create, to initiate the series of steps that are going to generate my visuals. As I said before, I'm going to be doing mostly two-dimensional visuals in this tutorial. So let's just start by using jit.gl.videoplane. Jit.gl.videoplane is a cool object. It's essentially just a flat, like OpenGL 3D object. So like if you used jit.handle and moved it around, you'd see how it's just square, essentially. But a square is exactly what we need to be able to display a two-dimensional video. You have, there's an attribute in jit.gl.videoplane called transform reset. If you give it a value of 2, it's just gonna adjust to whatever the size of your window is, which can be convenient. Like it just adjusts to the aspect ratio. If you disable the transform reset, like it's gonna adjust to the window size, but the aspect ratio is always gonna be square. So it depends on what kind of displays you're using, but for the time being, I'm just gonna use transform reset. One thing that is worth acknowledging about using transform reset is that you might not be getting you are altering the aspect ratio when it comes to displaying. So if for example, you were to send your GL textures out through Siphon server, they might look different because maybe on the other side, they're not being, like the aspect ratio is not being manipulated in the same way. So it's just something worth considering. Okay, so let's start by just instantiating a jit.gl.pix object. And if we just connect these two together, nothing's gonna happen. I'm gonna start by having the receive bang and creating a new jit.matrix. And it's gonna be 4 float 32. And I'm just going to have dimensions of 1080 by 720. So again, we're not going to see anything yet, and that's because most of the patching has to be done inside of the jit.gl.pix object. So I'm going to double click inside here, and I'm going to see that I have 2 inputs, in 1 and in 2. I'm actually not going to use either. I'm going to use an object called, well, because we're in the world of gen, these aren't quite objects, they're called operators. So I'm going to use the one that's called norm. So norm, what that gives us is that it gives us normalized coordinates of the input matrix. What that means is that, right, so we have a matrix that has dimensions of 1080 cells by 720. The norm object is going to normalize that from the input range to a range of 0 to 1. So instead of having coordinates from 0 to 180, we're going to have coordinates from 0 to 1. And instead of having coordinates from 0 to 720, we're going to have coordinates from 0 to 1. So this is just giving us coordinates as a vector from 0 to 1. And normally, well, there's no normally, but like this is usually very useful for resampling incoming videos or textures. But in this case, we're not going to use that for that. The cool thing about these vectors is that we can repurpose them for whatever use we want. So in this case, we're going to use them as actually our source of input. So if I just connect this here, our like positional vectors are being reinterpreted as kind of colors. So we can see how this corner is black and how this corner is yellow. So essentially what's happening here is that our vectors for x and y are being interpreted as r and g. So we can see how we increase in the x-axis, we're increasing in r in red, and as we increase in the y-axis, we're increasing in green. And as we increase in like the mixture of these two, we get yellow, and yellow is just a mixture of red and green. This is cool because what that means is that we can essentially just synthesize or manipulate numbers and vectors in whatever way we want to generate visuals. And usually this could be applied to you know, as being a texture, we can apply it on GL objects, like let's say jit.gl.pix. So we have that sphere, and now that sphere has that color, and it looks pretty horrible, but that's not really what I want to do right now. I want to like present it as a two-dimensional thing. So there's a lot of things we can do. So essentially now what we're thinking about is thinking about processing these incoming textures as our, maybe this isn't the best metaphor, but let's just think about them as our oscillators if this was an audio signal. And what we're going to do in between is that we're going to add like different processing stages. And one good way of starting is by separating them. So the output of norm is a vector, meaning that it's pairs of numbers. And we can think of this as, you know, it's outputting the vectors for all the entire image, like pretty much immediately. So we're getting vectors for the entire picture at the same time. So we can separate the vectors into streams of two like individual dimensions by using the Swiss operator. So we can get the x by typing Swiss x and the y-axis by typing Swiss y. So now the output of this object is going to be all of the x, like the x component of the norm vector, and Swiss y is going to be the y component of the incoming vector. So if we just connect Swiss x to the output, we're going to see just the x-axis being displayed because that vector has now been separated. So this is now a one-dimensional thing. Before we continue, actually, it's worth mentioning that the dimensions of the inputting matrix are actually important. We can use this as a kind of like a downsampling strategy. So we can just say dim. I'm going to use a pack object, dim 0, 0. So I chose 1080 by 720 just because it's nice. But if you wanted to use a different dimension, we can totally downsample it. And because this is really just one-dimensional thing and it's just colors, we won't really see the effect right now. But once we have more complicated shapes, we can see the effect that this has. So let's just leave it at 1080 for now. Okay, so, you know, there's a lot of very basic things we can do to these two vectors. We can start by, you know, multiplying them together. What effect would that have? Well, something that's always worth thinking about is the fact that we're working with like the amount of dimensions that we're working with. So in this case, we're just working with one dimension. So if we're only working with one dimension, we're going to get like a gradient from black to white. If we wanted to have more colors, we would have to add more dimensions. And essentially, each like dimension in the vector corresponds to a different color. So if we wanted to have, you know, let's say that we wanted to have this same shape, which is just the result of multiplying the x value against the y value. And let's say that we wanted to have like a positional offset by adding to it. Let's say I'm going to add 0.1. And then I'm going to multiply them together after adding that. And then we're going to join these two and form a new vector. That's actually going to have more color. Because now we have more than one you know, dimension to this vector. So let's actually think about what we're doing when we manipulate these numbers. Let's go back to Swiss Y. So if we separate them, whatever operations we perform on this are going to be reinterpreted as color manipulations, essentially. So let's say that we wanted to reverse this line. We could just have an inverse -1. So if we added this to the original, we would essentially, I mean, I haven't tried this before, but I'm assuming that we would just have a white. Exactly, because we're just, you know, we're inverting two gradients that add up to 1. But that could be cool if we wanted to combine them into 2 different colors. For example, we could just say vec. By the way, vec is kind of the opposite of Swiss. What it does is that it lets you combine different single dimensional vectors into multi-dimensional vectors. So I could easily just say, no, I could just easily invert this and have different colors. So it's always worth knowing that this out object essentially is going to interpret the vectors as colors. This gives us a lot of possibilities when, you know, manipulating those vectors in whatever way we want. And then we can do the same here and add a new color. So what started as, you know, just a straight line is now, I mean, not a straight line, but like 2 separate gradients is now a mixture of colors. And, you know, we get these nice like shades of purple when we get the mixture of blue and red, and then this like, I don't know, Aquarius kind of color when we mix blue and green. And the cool thing is that we can just perform any math that we might want. So instead of doing the inverse, I mean, we could just leave it as, you know, -0, which is just a lazy way of letting it through. Or we could even perform any function, like we could perform a sine function. And that's essentially just plotting a sine with that range. We could also, you know, amplify it so that, you know, to see what effect that has on the sine, and it's just essentially taking up more space. Another cool thing that we can do with this idea is that we can control it externally. So we can just use the param operator. So let's say, you know, let's just call this scale. I know it's a vague name, but it's just to demonstrate an idea. And we're going to have a default value of 1. And if we type the word scale here, it's just going to create like a remote connection between these 2 objects. So it's kind of like using a send and receive object, but just by naming a parameter, it's just going to find it wherever you instantiate it in your patcher. So what I can do with this is that I can go outside of the jit.gl.pix object and just write, what was the name actually? I forgot, scale. And I can just send the value from outside. I just control the position of that. And we can use any strategies that we already know from working with Max to control these these parameters that we have outside of our GL environment. So, for example, I could just use a cycle oscillator as an LFO, and I could use an abs because I just want to scale it positively. And then I could use a snapshot. So essentially, the cycle object is like synthesizing a sine. Well, it's not synthesizing; it's reading from a wavetable, but it's outputting a sine wave. And the abs object keeps all the values positive, and then the snapshot converts the signal into max messages. So we can see how the visual is being modulated by that sine wave, and we might want to increase that value. So let's increase it by 2, so it has a bit of a higher amplitude. Cool, so we can see how it's being changed. Another thing we can do is use like other math operators that the the jit.gl.pix environment has. Like for example, one I like a lot is the torus operator. So this just takes the equation of a torus, and so it'll apply like the shape of the torus following whatever dimensions you feed into it. And the cool thing about this is that it's actually gonna, like, instead of interpreting that formula for, you know, space and to form the object of a torus, it's going to interpret it as variations in color. So we're going to get like a pretty different result from what we might be able to see when we use, for example, a jit.gl.grid shape object with a torus shape, which is a pretty cool thing, because now we get this very beautiful array of colors being displayed from side to side. And the thing is that we get multiple values that are being output. We get the surface coordinate and the surface normal, so we can use those values to different effects. Okay, cool. So we could also add different ways of modifying our torus. So we can also use, for example, the scale one. So we can see how we're generating this changing pattern of colors just by using the modulation source that we had from outside. And maybe, you know, maybe you don't like the sine wave, but you know, that's up for you to decide when you're modulating your colors. And I think that this is already a very beautiful visual idea, and it's a really simple patch. A cool thing about this is that we can think of jit.gl.pix as being kind of like a modular thing. So it doesn't have to, like, we don't have to have a really complicated patch to keep going on. Like, we can keep working on this texture in a variety of ways, and it's going to be very flexible. So for example, I can just introduce a new jit.gl.pix. Now this is gonna, the thing is that it is very computationally demanding. I don't know how well this is being recorded. It looks quite smooth on my computer screen. I don't know if QuickTime is doing a good job of recording that. So hopefully you'd have a powerful enough computer to run all of these patches with a decent enough GPU. I'm just on a laptop, so maybe that's not the most powerful environment. But still, we can manipulate these textures in a variety of ways. So for example, another thing that I can do, let's explore another use of norm. Earlier I was making reference how we can use that to resample incoming textures. So let's do that. I'm just going to write sample over here. It lets us sample a matrix. And I'm going to grab norm. So what's happening here is that maybe I'm not doing the best job of explaining this, but this is kind of how I understand it to be. When you have an incoming matrix, it has kind of like implied coordinates. And what the sample object is doing is multiplying those implied coordinates by whatever coordinates you have here. So, you know, the matrix has, let's say, a given point in that matrix, and it's a point of 0.5 in that given vector. Let's say it has a y value of 0.5. Then it tries to match that point to whatever value this is being fed into the right inlet. So because in this case, the norm is just a straight line, of course it's gonna look the same because it's matching the incoming matrix position to the same matrix position. But if we manipulate these coordinates, it's gonna have to match it to a different position. So we can manipulate the location of different pixels or whatever in our texture. So what we could do, for example, is that we could, have our coordinates being multiplied by 2. So that means that we'll see our video twice, like our incoming matrix twice, or 4 times. So this creates a very easy way of manipulating like a sampled matrix. We could, as we saw before, we could also separate them into this, by using the Swiss object, we could separate it into the X and Y components. And what that allows us to do is to process the X and Y components differently. So we could, for example, reverse the X component, and we would use it back after, and leave the Y component alone. Or, times -1. or times -2, -3. That's what my finger wrote. A cool thing about GL is that we actually don't have to separate the planes to be able to manipulate them separately. So instead of having to use 3 objects, we could just use 1. We could just use times -3 and 1, and that would yield the same results. Because it understands that the first value is to be like it's the number that you're using to process the first value of that vector, and the second number is used to manipulate the second value of that vector. So that's pretty convenient. And another cool thing we can do is also use the formula of a torus. So instead of using it for generating the torus shape in jit.gl.pix, for example, or instead of using it to generate colors like we were in the other GL subpatcher, in this case we're going to use it to just manipulate, like distort the sampling of the incoming matrix. So we can just write here torus. So what this is doing is that essentially it's like spreading the torus in like 2 dimensions and like distorting the incoming coordinates and reapplying them in different positions. And the cool thing is that we don't have to leave it like this. We can process it before and after. So for example, we could say have a multiplier here, and we could have a smaller torus. So that's just a component of our video. And this is something that we could, again, modulate from outside. So what was the value I used? Scale. So I can just make another param, scale. And I'm going to just use the same modulation source because this is just for demonstration purposes. For an actual, work of art, like more thought would go into this, but this is just to show the idea. So we can see how it's resizing essentially the torus in and out. That looks horrible. So I'm gonna stop that. So maybe this isn't the best kind of spatial distortion that we want. I mean, maybe it is. Maybe, I mean, it's horrible to me, but maybe you dig it and that's totally cool. But instead of having this here, maybe we could have a different spatial manipulation. Maybe we could use a cone. And that's going to give us a completely different shape. And maybe now maybe that's cool. And what we can do actually is even include the shape we were using before, for example, the torus. And then we can crossfade between those two. So then I can just write a mix object. And essentially what I'm doing here is that I'm mixing between 2 different shapes of distorting space. So instead of using scale to change the size, I could use scale to mix between these 2 shapes. So let me just reconnect this here. So now I'm using that modulation source as a way of like changing the way in which I'm distorting the coordinates from the incoming video. And maybe that yields more interesting results. What else? We've spoken about how to generate colors and how to distort things with using sample. And another cool thing is that we can also use any objects to process textures to manipulate how this looks. So for example, I could just grab we could just use, for example, I have this, I took this from a Jitter group on Facebook. Somebody sent this abstraction. I mean, it's essentially just a jit.gl slab with this shader. And essentially what it does is kind of like an emulation of jit.slide, but for textures. So where I'm going with this is that we can use any jit.slab file to process our textures. So if there's any texture processing tools that you have at your disposal that you like using with textures, you can also reapply them and repurpose them here, which is really cool. So in this case, it's just kind of gonna have this effect of making things move slowly, because it's instead of going immediately from one value to the next, it's going to take some time to slide. So it just has this kind of looks like feedback, but it's not quite feedback. It just looks smoother. So it's a really cool way of working with these kind of things. And you can also use jit.gl.pass as well, and any kind of texture modulation that you might think of. But a second ago, I was talking about feedback, and I think that that's actually a really, really cool thing to talk about, because this kind of, it kind of looks like video feedback, but not quite. But the cool thing about feedback is that by adding, like explicitly having that extra stage, we can control it like manually, and that leaves us a different stage that that gives us a different stage in which we can add modulation steps. So we can just type jit.gl.pix. And what I'm going to do here is that I'm going to type jit.gl.slab. And what's happening here is that I'm going to take the output from this jit.gl.pix and I'm going to send it back into itself. So this is going to be slightly delayed because it has to go outside. It creates a new texture with the same kind of contents, and then they're being sent back. And instead of having a plus object here, I'm going to have a mix. And for now, I'm just going to have 0, just because I don't want to actually see the effects yet. So you might be wondering, by the way, if I disconnect here, it's still being displayed. That's just because essentially what's happening is that the texture has already been assigned, so it doesn't really matter if it's connected after a while. If you want to have a different texture, which is what happens when you instantiate a new gl.pix object, then you will want to connect it. Okay, so let's add a new param operator. Default 0 and mix. And what we can do is we can write this down from outside mix. And now we can control like how much feedback we're going to have. So that was kind of like an effect of oversaturating feedback. So the really cool thing that we can do now is that we can actually resample the feedback, so the feedback doesn't have to look the same as the original source. So I can just come in here and say sample, and then say norm. And the same kind of operations we did before, we can, like on like the previous step, we can also do here. So I can manipulate this by 1.1. So what this means is that every time that the sample is being resampled, it's being like resized as well. And it's being made slightly bigger. So it kind of just feeds back and changes size. And the cool thing about this is that even if we like oversaturate it, it's being displaced every time. So it takes a little bit longer for it to be, completely oversaturated. What happened here is that like I'm not exactly sure what this is, but it just kind of happens when the feedback is so much, you just kind of have to instantiate the texture. I assume that it's just because you oversaturated it, and not necessarily on a visual way, like maybe on a technical level, like it's just too it's permanently feeding back a negative value. But this creates a really cool effect. It's kind of like it has a path that it's flowing into, so it adds more depth to whatever it is that you're working with. And the cool thing again is that we can also modulate this. So I'm gonna add the scale. I keep forgetting the name, but param scale, and I'm gonna add it here. And actually, no, I'm not gonna add it here because scale is outputting a value between 0 and 2, and I want it to be slightly smaller. I still want to use the same pattern. I just want to scale. I want to scale. So the minimum is 0 and the maximum is 2, and I want it to go between 0.8 and 1.2. And instead of having this being, the thing about working in Gen is that if you have an operator with, like if you initialize an operator with a given value, it doesn't let you change it. So you have to initialize it with no value to be able to change it. So now it has no value, so I changed it, and I'm going to take the scale parameter and feed it here. So what's happening here is that now the sample is being fed back onto itself, but the size of the resampled texture is constantly changing. So it kind of goes in and out of this kind of spatial distortion. And let's say that we just wanted to move it on one axis. So we just wanted to change the resizing in one axis. Then in that case, I guess we would have to use Swiss and vec. So what we could do is separate Swiss x and Swiss y. And let's say that I just want to change the y-axis. Well, this is actually a really cool effect, but the thing is that it's making it like one-dimensional. So now it's just kind of considering only the y-axis. It looks very beautiful, but that's not what I was thinking about. So we're going to have to use vec 0, 0 to reincorporate the x-axis. So now it's only being modulated in one direction. Cool. So then if I want to smoothen that out, again, I can just use jit.gl.slide. So that's kind of what I meant by this being a very modular kind of like approach to working with visuals, because you can just keep adding more steps. It doesn't have to be an overly complicated single jit.gl.pix patch. You can have a bunch of them that are doing like subtly different things and changing things slowly. Okay, so let's just keep doing stuff. I mean, I like how this looks, but you can just keep adding. Another idea is that you can also use videos to, like pre-existing videos or other types of matrices to alter whatever it is that you have here. So let's start by gl.pix. Let's start with noise. So I'm going to take jit.noise. And I'm going to have the same dimensions as before. By the way, before I do that, actually, I'm going to erase this because it starts doing crazy stuff. You'll see it that if I change these dimensions, how the video is changing subtly. Like, it's not as obvious as I hope it would be, just because I want to just make a point out of this, but it's not that obvious just because there's a lot of processing happening in between. But now that we have smaller dimensions, our video is responding differently. So like maybe if I go I'm going to skip a few of the processing steps and I just come from here. Like you'll see how it's not as detailed as it used to be. Like if I increase the dimensions, it has a higher resolution. Which doesn't mean that it'll look choppy at all. It just means that the shapes are kind of blurrier and it has less detail, which can work for your advantage. I mean, like in different ways, like in one being an artistic advantage and the other being just a technical advantage, because it's going to be less processing if you have a smaller matrix. Let's have noise that has the same dimensions as whatever it is that our matrix is. Actually, no, let's keep it separate. But I'm going to start with 720 by 480. And I'm going to send it back. That's not what I was supposed to do. Nor is that. My bad. That explains some stuff. Okay. I need to add another jit.gl.pix, my bad. So now I'm adding this noise source against whatever video source is coming in. So this noise is like, we have noise being generated in 4 planes every time that we send the band from jit.world. I can change the number of planes. It's not really going to have much of an effect, but that's something that you could do. And as you increase the dimensions of the original video, you'll see how the noise, like the way in which it relates to the noise, is changing. It's becoming more of like a granular texture. But if these are really low, I mean, it's still a granular texture, but it has a different like scale and a different effect because of that different scale. which can be really cool. And let's say that we are back to our high resolution over here. We could also change the dimensions of the noise itself so that our original visual has whatever shapes it has, but our noise distortions are different. And we can also scale our noise if we don't want it to be that intrusive. So I can just say times 0.1, 0.2 actually. And the noise will be there, but it will be a little bit more subtle. And we can also choose to multiply it. So if we increase that actually now, times 2, it's just going to be different spots.